All right, guys, welcome to MS-100 again today. Today we're going to be talking about the missile part of my career. I want to share with you just some general information about the ICBM world and nuclear weapons and those kind of things. And also just kind of run through some of the things that I did during my career. So I'm going to periodically show you pictures throughout this whole thing. Let me start with this first slide. The first slide here is a drawing of the 321st Strategic Missile Wing up in Grand Forks, North Dakota. It's no longer around. They actually disassembled this a few years ago. But when I was missile launch officer, we operated in this missile field. This is basically, just to give you an idea of the scale, this is basically the size of the state of New Jersey, okay, the missile field. This is very, very large. From the support base, it would be a couple-hour drive down to this area, and it would be at least a couple-hour drive up to this area, and about an hour across in this direction. This is actually 3 squadrons. The top squadron up here, you can see above these dark lines, that's the 446th Strategic Missile Wing, then the 447th and the 448th. Yes, sir?
Why did it need so much room, sir?
The reason why is if you look at the little dots here, each one of these is a missile. Whoa. And each one of these the lines that come over, and at the end there's a dot, there's a missile, and then you see a little thing like this in each one of these. That's a launch control center for 10 of those missiles. And the reason it's so big is the idea was that they would be a minimum of several miles away from each other. And the idea was if something was to hit one of them, it wouldn't take out all the rest. And these are hardened underground sites. These are made of reinforced concrete, and if you drove by one of these missile facilities, you wouldn't even know that you were driving by it because it's level with the ground. It's got a railroad track, basically. There's a little trench dug back. It's got a little railroad track, and there's this big, huge, called the launcher closure door. It's a big concrete door that would slide back to expose the missile for launch. And that missile, you'll see pictures. I'll show you how tall it is. It's about 60 feet tall, and that entire missile is underground and surrounded by hardened concrete. And it has the ability to communicate with us via wires under the ground and also radio waves, and it has its own backup power system. So if you shut the power off, it's still operating. And it would operate for a long time.
I have one more question about that.
Sure.
Don't they have to surround it with like ice or something?
With ice?
Or
No.
something?
No.
Like,
The missile itself? Is that what you're saying, the missile itself?
Yeah, like for some reason, every time I see anything that has to do with a missile, when it's about to launch, I always see like frost coming off of it and stuff.
What you're probably seeing is the smoke from the firing of the missile, and it might look like frost in some cases, but it's not. Basically, this system, let me take this off so the guys elsewhere can see us. We'll jump ahead just a little bit here. If this is the ground level, the launcher looks like this underneath the ground, okay? And inside of this, you have a missile that's about 60 feet tall, okay? And when it gets ready to fire, there's a concrete door on top, and this slides back, which exposes this, and then this fires, and it literally throws itself out of the ground. This is called a hot launch system. There's also a system called a cold launch, which the Peacekeeper missile used, and also missiles at sea, because this basically burns up your launcher. When this fires, it puts out so much heat and vibration and all that it tears this thing up pretty much. But you don't want to do that on a submarine underground or underwater. So the way a submarine works is a submarine is a cold launch system, and on a submarine, like here's the top of the submarine, and here's your missile tubes. The missiles would be inside this launcher, and it's basically got stuff that seals it so that you can put compressed air underneath this until it's literally like a cork in a bottle and it pops it out of the launcher. And this can be popped out of the launcher, and then once it's away from the ship, then it fires. The beauty of a system like that is it doesn't destroy your submarine. You can go back and reload another one and fire out of the same hole. Nice. But with a hot launch system like the ICBMs I work with, it won't work. It burns it up. The exception to that rule is if you set up the site with all kinds of protective materials, which we do for our test sites, it burns, comes out of the hole, it tears up all that protective stuff. We take it down and then get it ready for the next shot. But that's a very unusual thing.
How many pounds of fuel does each missile hold?
Oh boy, I should know that. You're talking tens of thousands of pounds.
Like the maximum distance they can travel.
I can't tell you the exact distance for two reasons. One, I can't remember, and the other one is I wouldn't be able to tell you anyway because it's classified. But it's intercontinental ballistic missiles, so obviously it can reach from North America to Asia, okay, or Europe or wherever it's going. Okay. All right. So anyway, back to what we're talking about. Let me go back to our slide here. Each one of these is a squadron. Each one of these three is a squadron. Each squadron has 50 missiles. So in a typical wing, which is made up of 3 squadrons, you'd have 150 missiles per wing. Okay? And the thing that you can't tell, or that this doesn't tell you, is that each one of those has multiple warheads. This system, the Minuteman system, which is still on alert, not this wing, but there are still several out there, each one of these is capable of multiple independent reentry vehicles, which means each one of these missiles that gets fired can turn into 3 different warheads when it lands. So the way it works is, if you imagine this being a missile, as the missile comes off the launcher, it goes down range, and when it gets to a certain point, the only thing that's left is the front part. The stages with the fuel have fallen off. And as the reentry vehicle comes in, it basically can separate into 3 different warheads, and so it actually can strike 3 different targets. Or you could put all 3 on the same target, or whatever you want to do. So in reality, 150 missiles equals 450 warheads. Oops. So you can see that one missile wing is a very, very powerful unit. We used to laugh when we lived up in North Dakota because they had a missile wing here at Grand Forks and another one in Minot. They also had nuclear-capable B-52s at Minot. And so we used to laugh and say, if North Dakota seceded from the Union and became its own country, it would become the 3rd most powerful nuclear power in the world because they had so many nuclear weapons up in North Dakota. All right. They don't have nearly as many now because they've shut some of this stuff down. But there's a lot of power that's involved in this whole process. Okay. All right, let's move on. Okay, out at a launch control center, where the guys like me were, where we controlled this stuff, we also had an underground facility. And so you can see on the diagram here, this is what a facility would look like. You would actually notice this if you're driving by. You would see a barbed wire fence. It'd be sitting off the road, 200 or 300 yards. It looked kind of like a farmhouse or something, but it's got this big barbed wire fence. And it has a big building that could be a big farmhouse or something like that, a detached garage. What you can't see is all this underground. You would go down an elevator, and on one side you had the launch control center, which is where we operated. There was a 2-man crew at all times. And when I say 2-man, it could be male or female. You'd have a 2-person crew over here, and then you had a launch control equipment building on the other side. This was actually a large generator room, and it had lots and lots of fuel. So if we lost power to the commercial power, we could operate for days and days and days just running our diesel generator underground. In addition to diesel generators, we had batteries underneath here that could last for a long time too. So we had 3 different power sources. The whole idea was to make sure this place stayed up and running. The other thing that you see on here is all the communications. You can see a variety of stuff. We actually had UHF communications. We could talk to aircraft for a variety of reasons. We had satellite communications. We had HF. We had VHF for local traffic. We had underground HF antennas. If this one was blown away, we actually had the ability to pop 5 antennas up one at a time. If they were destroyed one after the other, we could put another one up. So we had a tremendous amount of capability that was underground that was very difficult to destroy.
What's HF?
HF is high frequency radio. UHF is ultra high frequency. VHF is very high frequency. It's all basically where it sits on the wavelength spectrum, radio wave spectrum. And so all of this was underground. We also had the ability to shut ourselves off. These were intake valves and exhaust valves. They were literally set up so that if they detected an overpressure of air, meaning something had blown up in the area, they would automatically shut off and seal us off from the rest of the world so we wouldn't be destroyed. And then after the pressure went back down, they would open back up and we could start operating again. And of course, during the meantime, we were still operating too. But we had 5 of these in every squadron. So there was 15 of these sites that were manned at all times. So in those 15 sites, you'd have 30 officers at a minimum operating these facilities. The way it worked, we had to have 2 people on duty at all times. That's basically what's called a weapons system safety rule. In the United States Air Force or the United States military in general, no one person can ever work on nukes by themselves. And the idea is you don't want somebody to mess around and do something that they're not supposed to. So what they would do is they would pair us up, and we would always work. Maintenance guys would always work in pairs. Operators like myself would always work in pairs. You always had a partner with you so that if anything got done, you had 2 sets of eyes watching it. Okay. The only time that we weren't physically working together was if one guy was taking a nap or resting for a while. One of us would operate the stuff while he was napping, and you might say, well, that violates the whole concept. Every piece of equipment had what were called positive operating seals. That's not right. Positive naming seals. I don't remember the exact word, but basically the idea was you couldn't open up and tamper with anything without breaking these seals. And we had to look at those seals. We had like a little flashlight. And you would look at those seals every alert to make sure nobody had messed with those while you were asleep or that kind of stuff. So there was all kinds of weapon system safety rules built into the system to make sure that nobody was messing with something when they weren't supposed to. All right. Any questions about the chart and what was out there? I'll show you a picture in a second. Okay. This is actually a picture of what topside looked like. Obviously, it didn't normally have a bus. The reason this bus was here is because I was taking some cadets out on a tour. But this is what the facility looked like. This is your UHF antenna, just the tip of it. It kind of looks like the top of a missile. People always ask us, what's the missile over there for? But it's actually an antenna. But you can see this is wide open country. You can see for a long ways in the distance here. This is actually in Wyoming, near Cheyenne, Wyoming. Not the facilities where I used to work at, but I was taking some folks. This was from the Air Force Academy. We brought them up. But you can see this is called a peacekeeper vehicle. It's an armored vehicle. These would patrol the missile field. We had, on site, we had 6 security personnel. And if we had an alarm out at a launch facility, one of those missiles I was telling you about, that were miles away, we would send the police out to check it out and make sure nobody was messing with our system. And all of those sites are guarded by some pretty sophisticated hardware and software, as you might expect. At a launch facility, not this particular place, but where the actual missile is, we had outer and inner zone alarms. An outer alarm is basically motion sensors that are topside. If something moves on that site, we're going to get an alarm. It's going to go off. We'll send the cops out. They'll check it out. The inner zone is basically if you try and actually penetrate into the facility. So if you opened up one of the hatches and inside there were locks to keep you out, if you started spinning the locks, we would automatically get an inner zone. Now we know it's not just an animal or something walking across. Somebody's messing with our stuff. So we'd get an inner zone, and of course that's a higher alarm. If you tried to tunnel into the system, we had motion sensors built into the concrete to make sure that you didn't tunnel into the system.
You really didn't want anybody getting in.
And they definitely work, because I can tell you there was seismic activity that we detected, earthquakes sometimes, in various places, and we would get seismic detections from our detectors in the concrete.
Did anyone ever actually try and break in?
While I was there, the only time we ever had one of our sites, a real alarm, was we had some protesters show up on a site, and there was a barbed wire fence around it, and they went over the barbed wire fence. We got an outer zone alarm, and at the time it was like it could be a rabbit, it could be a person, it could be anybody, right? So we send the police out there. As they were approaching the site, they called back and said, look, we got personnel on site, and then at that point you raise it to a different kind of alarm. We send a lot more police out to the area. And they were basically protesters they went out. They knew they couldn't get into to the actual facility. They got onto the site, but there was no way they were going to get through the concrete and that kind of stuff. So, most of the time they would basically make a big scene and then they'd be arrested.
Like what? No stop war?
Oh yeah, or throw paint on the, or red paint to symbolize blood or something, and make a scene and then get arrested.
What were they?
But nobody would actually get into these sites. And quite honestly, to make sure, even if you had the combo to the site, to make sure you were authorized, you would dial in the combos to the site, and there were 2 different combos, one that the security police had, one that the operators had. And the maintenance guys would dial in one combination, the security police with them that would escort them would dial in the other. They never knew both. And then once they dial in those combinations, it was called a B plug. It would start to lower itself. Imagine like a piston in a car, if you are mechanical. You know how a piston is a cylinder, and it has a piston that goes up the middle, right? And so you've got the cylinder, and you've got the piston. The B plug basically would go up, you know, if there's like a manhole that goes down into like a sewer, it looked kind of like that. This piston would go up into that cylinder and fill the cylinder so you couldn't get in. And that piston would take anywhere from 10 to 30, 40 minutes to drop down. We would set the timer based on how far away you are from security police. If it was a distant site that takes 20 minutes to get out there, we'd set it for 30 or 40 minutes. So those guys would dial in the combination, and then they'd just sit there and wait for 30 or 40 minutes for that thing to go down. And the idea was even if somebody had the combination, it would give us time to get out there to the site before they actually had access through the door. So there was a lot of safety things built into the system to make sure unauthorized people couldn't get in. All right. So anyway, this is what a site looks like. Inside, you would have 6 security police. You'd have a cook. You'd have a facility manager who ran the equipment topside, and then you'd have 2 officers downstairs who were actually operating the missile systems. All right. Each one of those crews would operate 10 missiles, and they would backup operate 10 others. So you'd have five flights in a squadron. The first flight would operate theirs and look at the second flight. The second flight would operate theirs and watch the third flight and right on down until the 5th was looking back at the first site. Yes, sir.
Did you guys name the missiles?
Every missile had a name, but it was just a standard nomenclature like Bravo 11, Bravo 13, Charlie 21, that kind of stuff. So the missiles were designated so that everybody would know which one you're talking about. All right. And actually, if you go back to this slide, you can see at each one of these, it's very hard because they're small, but each one of these has a number, a letter and a number, like Delta 36, Charlie 24. So you would know exactly which one you're talking about. Yes, ma'am.
Can you go back to, that one, okay. Is that an American flag?
This is an American flag on the front of the site, yes. This is actually the gate to the facility. This is a detached garage. This was the gate, and it had an automatic opener. So you would come up to the gate, and on your radio, you would call the police inside and say, this is trip number or whatever. We're here to relieve the crew. And they had been sent out information from headquarters who was coming. And so you would pass that information, and if you were the right people, they'd let you on site. But if you didn't pass the right information, then they would come up and jack you up, which means basically you'd have to exit the vehicle, and they'd put you down in the dirt, and then they would search you and find out who you are until they're satisfied that you were legit or not a terrorist threat. What's that? I was never physically jacked up. I never screwed up the information, and that happened to me, other than a training thing. But I saw it happen a couple times. I was actually on site. We were in an exercise. We had 4 officers on site, 2 downstairs and 2 upstairs, that were relieving each other. And I was upstairs, and 2 very senior officers from the wing came out. They were deploying to our site to be a backup battle staff area. And the colonels hadn't been doing this stuff for quite a while, so they're kind of rusty, and they sometimes would screw it up, right? So this full colonel calls in his information, and it was wrong. And the security policeman on site turns to me and says, hey, Lieutenant, Colonel so-and-so just passed bad info. I go, okay. He goes, what do I do? And I said, jack him up. And it was cold. It was like February. It was nasty out. And this is in North Dakota. I mean, we're talking like 40 below zero kind of cold. And so sure enough, they jacked up the colonel and searched and made sure they were correct, and then they let him in. And then the next trip came up behind him, another colonel, and he did the exact same thing wrong. And so he jacked him up too. And after it was all over, the second colonel came in, and this sergeant was feeling pretty low, like, man, I just did this to these 2 senior guys. And he started to apologize to the colonel, and the colonel says, oh, stop. He says, Sergeant, did I pass the information correctly? He said, no, sir, you didn't. He goes, you don't have to apologize to me. He says, we'd be having a conversation if you hadn't jacked me up. So, well, they had very, very strict rules because of the nuclear world. You had to make sure that you were doing things properly. And sometimes it was kind of hard on people to have to follow the rules exactly like that. But they just said, hey, there's no room for error when you're doing this kind of work. So anyway, let me show you a little bit more. These are a couple more pictures around the site. More communications gear you can see. These are those intake and exhaust valves. that would bring air downstairs and then exhaust the bad air. We used to mess around with some of the new police. I'll tell you, it's a quick story in a second. What's that?
How did they build that stuff underground?
This entire area back in the 1960s when they built it was completely dug out. It was a big, huge cavity. And they built the facility, and then they put the dirt back on top, and then they built this on top of it. So it was all dug out. I remember one time there was a new security policeman site. It was his very first tour out. And, you know, as a new guy, people like to mess with you, right? It's no different on active duty than it is anywhere else. Well, this guy was new. They said, hey, you need to do a ground system check. Well, there's no such thing. You need a ground system check. The guys downstairs need to measure the seismic vibrations. They made up this big story. And they said, go out between these two things and walk back and forth and stomp the ground so they can measure the vibration. And so he's out there stomping around. And, of course, they're talking to us. And we're talking on the radio. And we're in cahoots with these guys. And after a couple minutes, it's like, no, it's not registering. Man, you're going to have to stomp harder. So he's out there just pounding the ground. And finally, after a couple more minutes, no, still not registering. You need to jump up and down. And so this new guy's out there jumping up and down. And he says, what do I do next? We said, turn to the building and run around like a chicken because they're all laughing at you, man. And so it was just, stuff like that we always would mess with them together. But it's no different than any
Did you really even register on the sides of your box?
There's no such thing. We weren't measuring anything. We were just messing with them. Okay. This is a picture of yours truly and a couple guys that I worked with at the Air Force Academy. This is kind of the standard BDUs. This is not what missileers wore. They wore this kind of outfit. When I was on crew a few years before, it was all blue like this, but it was two pieces. It was like this uniform, but in blue. Then they went to a blue flight suit like this. This is a good friend of mine named John Corrigan. And then this guy, Lucky Araki, is actually a Japanese self-defense force officer. He was stationed at the academy with us and we just wanted to see the sites, so we took him out. And the crew members, my understanding now is they wear a green flight suit just like flyers do. So I just throw that in because I thought, it's a good thing about different uniforms over the years. This is inside of the facility upstairs. The guys that go out there would spend 3 to 4 days working out there. So you had to make, for some creature comforts, they would work for 12 hours. They'd have 12 hours off. And so upstairs we had a TV. Eventually they actually had satellites, so you could actually watch more TV. When I was there, it was like this basic 3 channels. I think that's an old stereo. They had some chairs. This is a pool table, and they had an eating area, a kitchen and eating area, and then they had 4 or 5 different bedrooms for the guys to stay in. Okay. In this case, you can see civilians. This is my wife. These are my crew partners' kids. This was actually Thanksgiving, and the wing commander said that our families could come out and have dinner with us. And so they just happened to be out on site, so got some pictures. This is me and my wife down in the actual control center. She and the others had come down to visit. She was actually pregnant with our first child. That's why we're kind of doing the belly thing. But anyway, this is the control console that I operated as a deputy. You can see all of these lights up here. There's lots of little lights. This is prior to the fancy computers that we have nowadays. We did have a computer, but it did not have a screen. You did everything. All of the inputs that came to you were via lights and printouts. And so each one of these lines was a missile, and if a certain light would come on, it would tell me, oh, we've got a failure of, something on the missile. And then this printout would come out, and it had a whole bunch of numbers, and I would have to memorize those numbers to know, oh, it's a 328, it's a 415 or whatever, and I would know what those things are. Some of these numbers, even to this day, I still remember, and it's been 24 years since I pulled alert. But we did this so much, it was just ingrained in your brain. And nowadays they have computers with screens like you guys would be familiar with, but not back then.
I was going to ask if it's a lot different now.
Yes, they've updated it in the late 1980s and early 1990s. They started updating this. But this system operated for 20 plus years and actually worked pretty well. Right behind, you can't see very well, but right over here there was a big computer. It was about 6 feet tall, about 3 feet wide, about 3 feet deep, weighed several hundred pounds. And we thought it was pretty amazing. It had 64K of memory. And we could operate all this stuff with that 64K. One of the problems we had, though, is we had a huge, it was called a magnetic drum unit. where we used to keep all of our targeting data. Memory is very cheap nowadays. You can get all kinds of memory on a small little stick now. Back in those days, memory was very expensive and it was huge and weighed a lot. So our magnetic drum unit was a 2-man lift. It was over 100 pounds for us to move this thing. And I'm sure my flash drive holds gobs more information than that thing. And the missile memory was so small that we had to literally, if we wanted to change some of the memory, we would have to dump what was in there, like erase stuff that was on there, and then send out information. And then after we had done certain things, then we would dump that, and then we'd send more information. It was very, very labor intensive compared to today's systems. They're so much more capable than what we had back then. So anyway, 64K of memory, and we thought, wow. I was just going to show you the basics of how to fire a missile. Firing a missile is similar to firing a gun. On a gun, what do you have to do to fire a gun?
Pull the trigger.
Okay, you got to aim it, right? And then what do you got to do?
Cock it.
Okay, cock it.
Safety.
Oh, no, okay, without a safety. Let's just assume, right? And then fire.
I would have said aim first.
A missile is the exact same way. It was basically 3 steps to fire. If we had ever got the order to fire these weapons, we practiced a lot, so we were very quick and methodical. But what we called aiming was called PLC. It was called Preparatory Launch Command. And we would basically, there was preloaded information on the missiles, and we would send a signal out saying, go to this target, basically. So now it's aiming. And then the next thing we would do is enable the missile, which basically meant that the missile was now capable of launching. This was a weapon system safety rule. We didn't want somebody to be able to turn the keys and fire this thing without it being authorized. So you had to have a code. And we didn't have the code in the capsule. Where do you think it came from?
The general.
Your mind. Through the generals from the President of the United States. If you have ever seen the President walking around, traveling, look in the background, you will always see a military officer following him carrying a briefcase. That's called the football. That's right. That's called the football. And this military officer has the football. And if there's ever a situation where our military, which is watching the skies and all that kind of stuff, calls the president and says, we have a launch, incoming attack, blah, blah, blah. What do you want to do, Mr. President? And they've already taught him all this stuff ahead of time, so he's not unfamiliar with the stuff. The president can basically authorize a retaliatory launch. Well, the codes for that are in there, and so they would basically send out information to the military saying, enable your systems, but without those codes, we can't do it. And that's to keep us from having a crazy guy, want to launch on his own.
After every fire, do they have to change the code?
Yes, you would have to change codes. Yes. And then the last thing you would do, obviously, is what we call key turn. And that's firing. Key turn is 2 officers in my system, about 15 feet apart. Each of us had a key, and we would insert the keys, and you never inserted the keys unless you were ready to actually key turn, because they won't come out. It's another weapon system safety rule. You would insert the keys, and then the commander would look at the deputy and say, on my count, 3, 2, 1, key turn, and we would turn the keys. They had to be turned within a fraction of a second of each other, or it doesn't count. It won't read it. So it's physically impossible for me to turn this one and run over and turn that one. They're too far apart. So that was what was called one launch vote. So one crew of 2 guys could produce 1 vote. And this was per capsule, meaning control center. So you needed 2 votes to launch. So that means another capsule also had to do the same thing we did. They didn't have to do it at the exact same time as us. If my crew partner and I key turned, and then 20 seconds later a missile got a signal of another key turn from another launch control center, then the missile would launch. Okay? But I could not key turn and then put the keys back and key turn again, and it wouldn't read it. It would say, I've already got a vote from you. I need one from somebody else. Again, weapon system safety rule to make sure at least 4 people have agreed that this is legitimate and we're going to do this. Yeah, Mr. Petkovich.
Do you think it would have been pretty tough if you ever had to fire a missile that would probably kill thousands of people, sir?
You mean mentally?
Yeah.
Yes, undoubtedly. And we had to go through psychological screening to make sure we weren't crazy people. We had to go through all kinds of stuff, and ultimately every person would get asked that question while we were going through training. If you get the order, are you capable of doing this? And if you couldn't answer yes, then they obviously would retrain you into something else. How do I know that I could have done that? I don't. All I can tell you is I at the time said, if the country's being attacked and we're retaliating to defend ourselves, yes, I can do it. But if it had ever really come down, could I have actually done it? I don't know. I never had.
Never been in that position.
Never been in that position. I can't honestly say. Here's the way you make sure that you can still get them off the ground. Each squadron has 5 votes possible because there's 5 capsules, right? There's 5 possible votes. So that's 10 different guys, right? 5 different crews of two guys. Only 2 of them have to key turn. So 3 of the 5 crews could refuse to key turn, and the other 2 can still do it. Because they're all interlinked in the same squadron, they're all tied together. So this was built into the system to make sure that no single person or single crew did anything wrong. But also they knew, if it ever got to that, would all 10 be able to do it? Maybe, maybe not. So they made it so only 2 had to. That's a good question. These are the machines that we actually use to do this. This is called the enable panel. And on this, it's hard to see, but this is like a combo lock. On each one of these wheels, there's 2 letters. And I don't remember how many positions there were on each, but it's several million combinations. So if you want to just start dialing in combinations and turning this little thing to see if it can enable the missile, yeah, good luck. You're talking several million. And, oh, by the way, as soon as you dial something in and turn this, every capsule in the squadron gets an alarm saying somebody's trying to enable the missiles. And if we don't have a message saying we're supposed to, we had procedures to stop launch to make sure that you weren't able to do anything. So anyway, this was the enable system. The next one here, this is the actual key turn launch device, launch control panel. And you can see it's got a key inserted right here. It's hard to see, it's on that from the edge. But basically, you just stick the key in just like a car, and you would say 3, 2, 1, key turn, boom, and you turn it. And that's all it was. This was called the inhibit switch. If somebody was trying to launch when they weren't supposed to, we could actually use this as much as we wanted to stop a launch. Okay. But if 4 guys voted correctly and got 2 capsule launch votes, it didn't matter how many times we hit this, we couldn't stop it. That was designed to make sure somebody at the last minute doesn't say, hey, you know what, I don't believe in nuclear weapons, I'm going to stop all this. Okay. So anyway, those are some of the panels that we would use. This is the launch facility. I drew the picture for you on the board. Obviously, this is much better. You can see the missile inside here. This is equipment around it that keeps it up and operating, batteries and other things. This is that launcher closure door that would come off the top. It also had a underground equipment building that could produce power if the electrical power was shut off. And these are those access ports I was telling you about where they had the B plug where it would keep people from being able to get in. It's a very, very sophisticated system. All built back in the 1960s, but it's been upgraded numerous times over the years to keep it state of the art in many ways. People always ask me, how do you move a missile? This is how you do it. This is called a transporter erector. And basically the way it works is the missile is laying on its side inside this transporter erector. This is a parade. This was just in the background, but I got the photo. So the missile is laying inside, and you drive it out just like on a regular tractor trailer kind of thing, like guys hauling stuff to the market or whatever. And you pull up to the site, and you back up over, or basically right next to the silo, and then this whole thing stands up. It's got a hydraulic system that stands the whole thing up, so now the missile is standing upright. And then all you do is it's lined up over the silo. Then you basically just lower it down in with a crane into the silo. And then once it's in place, this thing goes back down, and then it drives away. And then another vehicle pulls up, looks like a tractor trailer again, and it pulls right over the top. And they open up the top of the silo, and the bottom of the van opens up, and then they lower down the warhead and actually made it to the missile. So the warhead is not transported in this vehicle, it's transported in a separate vehicle. And then we put all that stuff together, and then once all that's mated and hooked up, then it's ready to go. Yes, sir?
Wouldn't it be dangerous to drive around warheads, sir?
Very. And if you ever saw one of these, you would know it was going by, because there would be a vehicle not quite as big as this, but it looked like a tractor trailer going down the road. It said U.S. Air Force on the side. It doesn't say, nuclear weapons on board or anything. But there's this vehicle going down the road, and it would be escorted by numerous police vehicles, as well as those armored peacekeeper vehicles I was telling you about. So there would be, it was called a warhead convoy. There would be numerous police, and there was also a helicopter flying over the top, looking out in the distance to see if anybody was hiding, trying to ambush and all that. And if something went wrong, if anything went wrong with that convoy, they had to stop. It was an automatic security situation. So let's say the helicopter's flying along, and the helicopter has mechanical troubles and has to land. Has nothing to do with somebody attacking it. It was still an automatic security situation because people are saying, we don't know for sure, so they would send more cops out in that area. You'd have federal marshals traveling with this convoy, so if somebody wanted to stand in the way and say, I don't believe in nukes and the whole bit, they could be arrested by civilian authorities, not by the Air Force. You would get an awful lot of attention, anytime you were around one of these convoys. And these convoys stop for nothing. They stop for nothing. Unless something breaks down, like the vehicle itself breaks down. But if one of their security vehicles break down, they keep moving. And then others come along. And we took no chances with any of this stuff. If we had security situations, trust me, we had lots and lots and lots of police that would show up. I remember one time I was on alert. It was not one of my missiles that I was watching, but I was listening to the radio traffic between headquarters and our local stuff. And I hear guys down, it was in Mike flight, and they said something about, Mike so-and-so flight, security police on site have reported being fired upon. And of course I immediately was like, holy cow, somebody's shooting at our cops out on the site. And so anyway, they started rolling police out to the area. And I don't know how many police were out there, but trust me, it was a ton of Air Force police, local police, federal police, on and on and on. And what it ended up being was a couple local guys out hunting, and they fired, not at the guys, but in the general area.
One of those didn't even know the convoy was there.
Well, they didn't know. They were just near a site. It wasn't even a convoy. It was just a normal missile site. But these police were on site. They didn't even know they were there. And they fired at ducks or something in the area, and these guys said, holy cow, they're firing on us.
Did they get in trouble, sir?
They came out, they jacked them up, figured out who they were, and eventually they released them because they realized, hey, these guys were just out hunting. So, no, they weren't in any serious trouble, but they took their time making sure that they were really local guys and not, some terrorists in the area. Yes, sir?
Do you think that the system that it has to protect the nukes is truly impenetrable?
Well, I guess nothing is impenetrable, ultimately. Is it as safe as we can make it? Pretty much. I was actually in graduate school after I had done my missile duty, and there was a big fire in Montana, and it swept through the missile field up there in Montana. And, the newspaper was saying, oh my gosh, fire burns over 15 or 20, missile sites. Oh, they were trying to make a big deal of it. And some of the guys in my class who were from the Navy and Army and other services, we were all working together going to school. They were like, holy cow, what are you guys doing up there? And I'm like, it's no big deal, guys. Fire can burn right over that side. It didn't hurt anything. I go, what do you mean? I said, it's all underground. It's underneath concrete. Oh, but that fire left a little smudge on the outside, but it didn't hurt that side at all. Worst damage might have been maybe it burned the electrical line coming in, and the diesel generator came on underground. It's been running for days until they get a chance to fix it. No big deal. But we're still talking to it. We have underground communications through wires. We have radios. We have all kinds of stuff, so it's no big deal. But no, none of the sites have ever been penetrated. We have had people actually try. They came out and try to jackhammer the concrete and all that. But within minutes, the security police are there. They get arrested and all that kind of stuff. But they're very, very secure, and we've never had a serious incident where they got in or anything like that. And I that was the least of my worries. I wasn't concerned about that kind of stuff at all. Okay, let me show you what the missile looks like. This is actually a wiring diagram, but just to show you, you can see this is approximately 60 feet tall, and it has 3 stages: first stage, second stage, and third stage. It's ballistic because it fires, and then eventually it goes by inertia, right? This is not powered the whole way. The first stage basically gets it off the ground and gets it going, and then it separates once it's burned out to get rid of the weight. Then the second stage pushes it, burns out, and then they drop it to get rid of the weight in the third stage. And by this point, it's actually going up into the outer atmosphere or the lower reaches of space. And then what you have is the propulsion system rocket engine, which we call the pisser, and the missile guidance set, and then you have the reentry vehicle on top. This is the only part that actually comes back in downrange. And then when it comes in downrange, it can hit all one target, or it can split into 3 different targets. This is what the flight profile looks like. Here it is in the facility underground. This is us controlling it miles away, but they just put it in here to make it look so you can see it. And you can see the first stage gets it off the ground and burns out. Second stage, third stage, or no, excuse me, second stage, this is the shroud coming off, second stage here, third stage, and then you can see that it's getting up into the upper atmosphere or in lower reaches of space. The apogee is the highest point that it reaches, and then it starts to re-enter. And this thing is going thousands of miles an hour by the time it gets to this point. And then you can see the warheads are actually armed as they come back in. And then depending on whether you want it to burst in the air or the ground, the weapons will go off. People might ask, well, why? What do you mean ground burst, air burst? What would be the difference? If you want to affect a large area, you detonate above ground, like maybe several thousand feet up. And that way the blast effects go over a much greater distance. Because if you hit the ground, it digs a hole and it isolates the blast effect. But there are advantages to hitting the ground and exploding. If you're trying to go for an underground target, you want it to hit the ground and penetrate and then blow up. So depending on what you have it programmed to do, it'll do either one of those two.
Doesn't the radiation poison stay there a lot longer if it hits ground too?
It could. I mean, I'm not a physicist and I'm not an expert on all those things, but depending on how you burst the weapon, where you do it and all that, yes, it determines how long things will be contaminated and those kind of things. Yeah, exactly. Exactly. What questions do you guys have? I'll leave that up. That's how to shoot a nuclear missile and the nuclear business in 40 minutes. Yes, sir.
Hiroshima, I
Yes.
believe that's where they used the nuke.
They did one of 2 places.
Did they detonate above ground or on ground?
My understanding is they were airbursts, but it's been a long time since I've read all that stuff, and I can't remember. Do you remember airbursts? Those were 20 kiloton bombs, roughly. The warheads that we're using are several times larger, and these are not even considered large warheads on the missiles that I was using. There are others that are measured. Those were measured in kilotons, which are thousands of tons. There are other weapons that are much bigger called megaton weapons. Those are measured in millions of tons. And so you can imagine the size. I mean, some of these weapons are massive, not just in the size of the weapon. They've miniaturized over here with new technology, but or over the years. But the amount of energy they put off is tremendous. Some of these weapons are very, very large. Some we experimented with in the 50s were as big as a Greyhound bus. Yes, sir.
Do you think that since you've been in, the nukes have gotten more smart?
The nukes are more capable. They're smaller. They're more capable. There's less of them. We actually had a lot more nukes in the 70s and 80s than we have now. I'm going to talk to you guys about arms control on Thursday. That was my job in the latter part of my career. President Reagan, President Gorbachev, and others came to the conclusion in the 1980s, I mean, how many is enough, right? I mean, we've got thousands and thousands of these things, tens of thousands of nukes. And so in the mid to late 1980s, they started negotiating, and we signed the INF Treaty, which eliminated an entire class of nuclear weapons. And then we signed the START Treaty, which is the Strategic Arms Reduction Talks. And over the last 20 years, the United States and the Soviets, later the Russians, have cut, and we have literally destroyed thousands and thousands of nuclear weapons. I mean, there are still several thousand out there, but we have destroyed lots and lots of them.
How do you destroy a nuclear weapon?
You basically take it apart and you destroy the casing, and the fissile material is either stored or
Separated.
I guess, yeah, separated, and there's all kinds of things they can do to it. Another question?
If they're transporting one of the missiles for the warheads,
Yes.
and there's like a giant traffic jam, what do they do for that?
We never have to worry about that because these are all really remote locations where we have these. They're in North Dakota, Montana, Wyoming. We used to have them in Missouri and South Dakota. But due to the locations that we've chosen, they're outside of metropolitan areas. So you're talking about wide open country. You're talking about like, a place like Skull Valley or something. I mean, you never have, You never have traffic jams. And even if they did, if there was traffic in the area for some reason, like a wreck or something, the security police and all that, they would literally go forward to those places and get stuff out of the way, and they would roll right through. Yep.
What is currently the biggest bomb?
The biggest bomb out there? I really don't know off the top of my head. It's been years since I've been involved in all this kind of stuff. And I just don't know. It's not that I can't tell you, I don't know. Yeah.
So say, I'm not saying this is gonna happen, but say the transportation vehicles, both of them were being attacked, and, okay, first, are they transported at the same time, or do they do that?
No, they're transported separately.
Okay.
Mm-hmm.
But say both of them were attacked and taken, both of them, and they assembled it, would they not be able to shoot it off if they didn't have it?
You have to understand these things are huge. I mean, a 60-foot long missile that's, several feet around. Even if you could take over the vehicle, I mean, the response that we have with military is so great, you're not going to move it out of the area quickly. So the chance that you would be able to move it to someplace, safe is just not realistic. Even if you had the missile and had the nuke, without a facility to actually fire it from, even if you could put them together, that's unlikely or impossible, essentially. You don't have the right way to fire it because it has to be set up properly and all that kind of stuff, and calibrated and all kinds of things. So it's the chance of something like that happen is just, beyond reasonable. Yeah. And remember, it's not like North Dakota. You're going to have a bunch of terrorists come rolling into some small town in North Dakota and blend in. They're going to stand out if they're not Americans in some of these areas. And believe it or not, some of the local civilians would help us. Every now and then, they almost scare us a little bit. We would get an occasional phone call or something weird saying, Farmer Joe's got a missile that's a quarter mile down the road from his house, and his field's surrounded. So he kind of like, that's my missile, right? We'd get phone calls occasionally that would say, hey, some guy was messing around, some protesters were out there. Don't worry, guys, I ran him off. We're like, oh my gosh, you didn't shoot somebody or whatever, did you? But these guys could be very protective, and they would let us know if they saw anything suspicious and that kind of stuff too. So if somebody wanted to mess with these things, they're not in easily accessible places. So anyway, what other questions you have?
So we have 1 minute left.
1 minute? Okay, let's go ahead and shut this thing down.